when electric field and magnetic field are applied simultaneously perpendicular to each other, then it is called cross field. So we will discuss here the motion of electron in simultaneous application of cross field or simultaneously electric field and magnetic field. So first we consider two plates that are charged, so that the region between the plates will have electric field E. The region between the plates will have electric field E, and similarly we will also apply magnetic field in the region between the two plates. If the upper plate is positive, the lower plate is negative, then the direction of electric field is from positive plate to negative plate, and the cross sign denotes the direction of magnetic field B perpendicular to this screen. Now when a fast moving electron or charged particle enters into the region containing both electric field and magnetic field, the charged particle will experience two forces: electric force as well as magnetic force. The electric force, according to the figure, the electric force will be directed upward and due to which the path of the electron may be deviated in upward direction. The path of the electron may be directed in upward direction. And the magnetic force will be directed in downward direction. If we consider the direction of magnetic field, the velocity of the electron, then the direction of Lorentz force is downward. So if only magnetic field will be present, in that case the electron may be deviated in downward direction. So if only electric field is present, the electrons are deviated in upward direction. If only magnetic field is present, the electron is deviated downward direction. Now when both the electric field and magnetic field are applied, the value of electric field and magnetic field are so adjusted that the net force in upward direction is equal to the net force in downward direction. That is, the net force due to electric field is equal to the force due to magnetic force, or EE is equal to PEV. This gives the velocity of electron in the cross field. At this condition, when both the electric field and magnetic field will be equal, the electron will pass through both the fields in a straight line without deviation. That means it will not go upward, it will not go downward, it will go straight, because the two forces are equal to each other, so they cancel each other and the electron move undeflected. Now in Thomson's experiment, the electron which enters the cross field is provided kinetic energy due to some application of potential. Then, as we know that if the charged particle is accelerated through some potential, or if electron is accelerated through some potential V, then the kinetic energy developed in the charged particle or electron is given by EV. or half mv square is equal to ev, or v is equal to 2ev by m root. We will use this concept over here. So this gives the value of E by m. This was the concept mentioned by Thomson in his experiment, Thomson's experiment, in which he was able to calculate the value of E by m by passing the accelerated electron through the cross field. And now we will use the concept of cross field to solve this numerical. We have the first question. A beam of electron moving with a velocity of 5 × 10⁶ meter per second passes between parallel plates 1 cm apart. A magnetic field of 0.05 volt is applied to keep the electron undeflected. What is the potential difference between the plates? So we will consider two plates. And the separation between the two plates is 1 cm. And now some potential B is applied between the two plates, so that the electric field will be given by E is equal to B by T. And also magnetic field is applied between the plates. B. So value of magnetic field B is 0.05 Tesla, and when electron is passing through this cross field, the electron is undeflected. So for the condition of undeflection, condition, the electric force and magnetic force will be equal, and the condition is velocity of sound is given by E by B as discussed above. So the value of B is also provided, 5 × 10⁶ meter per second. We will give these values to calculate the electric field between the two plates. So 5 × 10⁶ is equal to E by 0.05. Therefore electric field is given by 2.5 × 10⁵ volt per meter. Now as you know that electric field is equal to voltage applied by separation between the two plates, we need to calculate the voltage. Electric field is 2.5 × 10⁵, and capital B is unknown. D is 1 cm, that is 1 × 10⁻². So this gives the value of potential between the two plates as 2.5 × 10⁻³ volt. This is the answer. Now we have the second question. In a Thomson's experiment, the voltage across the plate is 50 volt and the distance between them is 3 cm. So the two plates are separated by 3 cm and the voltage between the two plates is 50 volt. So voltage applied is 50 volt, the separation is 3 cm, that is 3 × 10⁻² meter. So electric field between the two plates will be V by D is equal to 50 by 3 × 10⁻² is equal to 1666.67 volt per meter. Next, the magnetic field applied to make the beam undeflected is 10⁻⁴ Tesla. So magnetic field is 10⁻⁴ Tesla. What is the velocity of the electron passing between the plates? Velocity of electron is equal to what? So again for on deflection condition, we know that the velocity of the electron is given by E by B. Calculate the value as 16.6 divided by 10 power minus 4. This gives 1.667 into 10 power 7 meter per second. This is the answer. Again, we have another question on the same topic. In a Thomson set apparatus for determining E by M of an electron accelerated by 2.5 kilovolt enter the region of cross electric and magnetic field of strength 3.6 into 10 power 4 volt per meter and 1.2 10 power minus 3 Tesla respectively go through undeflected. Determine the specific charge of the electron. So the question is simple. Here the accelerated potential is provided as 2.5 kilovolt, that is 2500 volt, and the applied electric field E is 3.6 into 10 power 4 volt per meter. Similarly, the applied magnetic field is 1.2 into 10 power minus 3 Tesla. And now we need to calculate E by M is equal to what? If on deflection we have direct formula for E by M as E by M is equal to E square by 2BP square. Now substituting all these values, 3.6 into 10 power 4 whole square by 2 into 2500 into 1.2 into 10 power minus 3 whole square. Calculating these values, we get our answer as 1.8 into 10 power 11 coulomb per kg, which is the required answer.